Welcome to Math Mini Lessons. My name is Sarah, and in this video we're going to break down the Algebra 1 Regents in New York for August 2024. And we're going to use this to practice for future Regents exams. So what I want you to do is you're going to look into the comments and you're going to, in the description for this video, and you're going to find a link to this exam. And I would like you to either flip through it and identify which questions you feel you want to see solutions for or need practice for, or better yet, do it yourself. Take some time, take the test yourself, and then watch this video, and I will not only give you the answers, but then I will break down each question for you so you can see how I solved it if you wanted to see that breakdown. All right, so besides that, I also have the link to the TI-84 calculator in the description as well. So if you do not have a calculator, you can have one of these. And if you're using an iPad, even better, you can actually write and have this video in the corner, so you can do all these things at the same time. With that said, we're going to get ready to jump into number 1, so get your copy of the test ready, and we'll start breaking down this Regents exam. All right, let's jump into number 1. Our answers are 4 and 1. Check off with your own work. If you got these two answers and you feel pretty confident, keep going to the next chapter. If not, stay here. We're going to break it down. So we're going to start with the first one where we're trying to factorize this polynomial. There are multiple terms here. There are 3 terms actually. And we want to factorize it into 2 binomials. So we're going to multiply those together. So how do we do that? Well, let me rewrite this here. And I want you to think of these terms as A, B, and C. And what we're going to do is we're going to try and figure out the factor pairs for the product of A and C. So we multiplied those two together. So here's our C, and even though we don't see a number in front of this X, there will be a 1. So what will be the product of 1 and negative 12? It would be negative 12. So I want the factor pairs of negative 12 that add up to our B term, our coefficient positive 4. So that's our goal. So it has to add up to positive 4. Okay, so I'm going to put negative 12 up top. And I'm just thinking about some factor pairs. I know one's going to be positive and one's going to be negative. And I like to start with the biggest ones, 1 and 12. And I think 2 and 6. And 3 and 4. And I know I don't have any more because the next one would be just 4 and 3, which is already here. So I know I have listed all my factor pairs. And in my mind, I'm kind of going in order, going from the smallest factor first up. And just thinking about his partner until they repeat, and then I know I'm all done. All right, so those are my factor pairs. I know one is positive and one is negative, and I know I'm supposed to add them up together, and when I combine those, I'm supposed to get positive 4. So how can I, which of these, when I think about them here, one is going to be positive, one negative, will get to a negative 4. These two right here. So how do I know that? Because in my mind, I'm already thinking of the difference between 2 and 6. And I know that the difference between them is going to be 4. So how can I add them up together to get 4? Well, I know one of them is going to be negative. And because my answer is going to be a positive number, I know the bigger factor has to be positive. So I'm going to add negative 2 and positive 6. So does that make sense? Because again, I know this is supposed to be a positive 4. So it makes more sense to me when these two integers combine. I want my answer to be positive as well. So this is telling me that the bigger term had to be positive. So that's what I was thinking in my head. All right, so I know I have negative 2 and 6. Those are my terms. Negative 2 and positive 6. So I know I'm going to have x minus 2 times x plus 6. And that's what you have here in 4. There's my answer. So that one, I know it gets a little bit tricky because one is positive and one is negative. But it does help if you start thinking about, when I combine two integers that are different, when one is positive, one is negative. It's kind of like a one-on-one fight. The one, I'm going to have a lot of zero pairs in there. We're going to lose some battles. So who do I want winning the fight? Do I want my total to be a positive number or a negative number? And that's going to kind of help you as you're going through these, through all your factor pairs. Okay, let's look at the second one. And in the second one, we want a linear function. So again, the only way that really happens is for something to be linear, whether it's a positive slope or a negative slope, is you want to have a constant rate. And it means that the difference is always going to be the same. I'm always adding or subtracting the same number. And it also means that I want my x to just either to the first power or just have an x. So for example, 3x is going to give me a linear rate. So let's look at our kind of examples here and try and think, where am I going to have the constant rate? Like it's never going to change. I'm always either adding or subtracting the same number. I'm always going to get the same difference. And the first one, I have a rate. A printer can print 1 page every 3 seconds. That's constant. That's why it's our correct answer. With the other ones, and this is the kind of one where you kind of should look at the other ones just to rule them out. In the second one, we have a bank earning 0.5% interest every year compounded. So that means because it's compounding, it's adding on to itself. So it's not going to be constant. It's going to get bigger and bigger. And in the second one, we have an organism doubling every 4 days. So you can kind of think, I'll have 2, then I'm adding 4, then I'm adding 8, then I'm adding 16. That is not a constant rate. And in the last one, we see a percentage here. It's decreasing by a percentage. So that means each year the number is decreasing by is going to change because it's decreasing by 1%, not by 1.5, but by 1.5%. And that's kind of your big clue. If you see a percentage or if you see something that says double or triple, not constant. And therefore it's not going to be linear. All right, hit pause and jot this down into your notes. Let's look at numbers 3 and 4. The answers are 4 and 2. Check with your answers. And if you got them, keep going. If not, stay right here. We're going to break them down. With the first one, we want to know which expression is going to be equivalent to this one over here. So in other words, I need to simplify it. And I'm saying that because I'm looking at all these answers here and I can tell they just combine like terms. So we're going to do 2 things for this one. One, let's just start by just writing it out. And I could already see that I'm going to have to distribute because the 3 is on the outside. And then I know I'm going to subtract our second term here on the right. Okay, so I'm going to have 3x squared minus 6x plus 9. And I know I'm supposed to just subtract. And actually, there are 2 ways I can see this happening. I could either see as I'm distributing -1, so I have minus 4x squared minus 3x plus 1. So you can leave this linearly and just leave it all together. Or you can stack, whichever one you want. Because I think most kids think from left to right, I'm going to just combine my like terms here. Like I'm identifying them. And I'm just going to put them next to each other. Okay, so I have 3x squared minus 4x squared. Kind of putting those 2 together. I don't need to put them in parentheses, but I kind of want them together because I know I'm going to combine them. And I'm going to end up with negative 1x squared or negative x squared. And now I have negative 6x minus 3x. These are going to combine, put them all together. They're all negatives, so I'm going to have more negatives. So minus 9x and positive 9 plus 1. We're going to combine those like terms and we're going to get 10, positive 10. And we can see our answer for number 4 right there. So that's one way you can do it. That makes sense. Another way you can do this that I also believe makes sense is you can just stack them together. So I could have put 3x squared minus 6x plus 9 and then just put on right underneath it minus 4x squared minus 3x plus 1. And kind of in your brain, you're still combining. Like, I'm still looking at it this way. And it just makes it, maybe this way makes more sense to you when you're adding them up together. Because you're still combining them. You're still pulling the things together. So that could work as well. Whichever one works. Is, I like, you can either stack it and you can kind of just see the terms together, or you can write them linearly. I like to just put them next to each other. Whichever way works for you, vertically or horizontally. All right, let's look at the second one. The second one was a little funny the first time I read it. We have Adeline's first birthday party. We know that her guests all bring $1 in different types of coins. So they're giving nickels, dimes, and quarters. And we know that they're going to add them all up together. And however many they get, the kids are going to have $1. Okay, so we know that. What we don't know is how many. And we know how much these are all worth. So I know nickels are 5 cents. We know dimes are 10 cents. We know quarters are 25 cents. We just don't know the quantity for it. So what other information do we have from this problem? We know there are twice as many dimes as nickels. So I know I have 2 times as many dimes as there are nickels. So why am I writing it like this? I want you to think about this. 2 times as many dimes as nickels. So for example, if I have 5 nickels, 2 times 5, then I have 10 dimes. So you kind of see why I wrote it in that way. So if I only had 4 nickels, then I would have 8 dimes. So that's why I kind of wrote it as 2n is equal to d. So that's helping us see, like, all right, my dimes is going to be 2 times bigger than my nickels. Okay? All right, and then I have 12 more quarters than nickels. So whatever my quarters are, I'm going to have 12 more quarters than nickels. So whatever my nickels are, I'm going to just add 12 to them. So if I have, let's say I have 5 nickels, if I added 12 together, that's telling me I'm going to have 17 quarters. So that's kind of what's helping me kind of visualize this all together. All right, so that's what I'm looking for in the problem. And so when I look at my choices, I need to just eliminate the ones that don't make any sense. The first one here, this is just like a basic one, but it's telling me my nickels, quarters, and dimes, but it's not telling me anything else about the twice as many dimes, or that I have 12 more nickels. It's not giving me any of that. 12 more nickels and quarters. Can't be that one. And the second one is telling me, all right, I have 2x next to dimes and x plus 12 next to nickels. So this is interesting because look at what they're doing to nickels. That instead, they're one saying, like, when I have my nickels, I'm going to multiply it by 2x. This part over here. So I'm going to multiply my number of nickels to get my number of dimes. So D is equal to 2n. That's what they're putting here for our dimes. Our 2x, 2 times the amount of nickels. That's what's happening in this part right here. And then the second part, they're taking the quarters and they're adding x plus 12. So they're saying take whatever the nickels are and then add 12. So both of those things are actually happening the way we represented them. So instead of dimes, they're just substituting it. Okay, so that's what's happening in this one. That's why 2 is the correct answer, because they're subbing in for nickels. Okay, hit pause. Actually, I just want to make sure you also see why it doesn't work in the next one. And number 3, why is it that we have 2x times the nickels? Because, and they have the quarters here. They're just setting, is this part right here that's wrong. They're putting 0.5 times 2 times the number of nickels. That doesn't make sense there, because we know that that's what's equal to dimes, not to nickels. And here in number 4, they're also doing the x plus 12 to the nickels, but they're doing it towards the nickels instead of where the quarters are. They're not subbing in the right place. Okay, so let's hit pause and jot this one down into our notes. Let's look at 5 and 6. The answers are 1 and 4. Stay here if you want an explanation for either one. If not, move forward. All right, for the first one, this is just some vocabulary terminology with polynomials. So in 5, they're saying a student creates a 4th degree trinomial. So trinomial just means I'm going to have 3 terms, and 4th degree means that my x is going to be to the 4th power. That's my 4th degree. And then it also says my leading coefficient, I want to have the wrong part here. My leading coefficient is 2. So that means there's going to be a 2 in front. That's my coefficient. It also has my constant value. Let's change the color on this for a second. My constant value is going to be 5. So my constant is, I like to put it in order, so that means my constant is going to be all the way on the right. Is going to be a 5, so a positive 5. So what could it be? So I don't need to know what the middle term is. I'm just looking for which one of these has those 2 other things to be true. So it starts with 2x to the 4th and ends with a 5. So in the first one, I have 2x to the 4th. And a 5, and that's why it is the correct answer. So why are the other ones not true? For number 2, I have the 2x to the 4th. That's great, but it has a 3 here at the end. The 3 is a constant instead. So that's why that one's wrong. With the second one, notice I have the 5 at the end, but I don't have over here, neither is it to the 4th degree, and my coefficient is supposed to be a 2. So cross that out. And then with number 4, multiple things wrong. Mostly being here, I have wrong coefficient, wrong term, and I have the wrong constant. So nothing is right. So there we go. That's why 1 is the correct answer. Okay, just some vocabulary terms. Let's look at number 6. When solving the equation, we want to see what Laura wrote, and we want to figure out what her first step actually was. So something happened. So she started off with this. And then next she had this. So you're really looking for like, what's the difference? This is really one of those like look and figure out what's different about these two and what made that difference. So clearly you can see that the difference here is like somehow this went away, and then we changed this into from a 0 to a 16. So 2 things happened there. So why would that happen? How would I get that 0 pair? The only way that can happen on the left side of the expression is if I created a 0 pair, if I added a positive 16, now this creates a 0 pair. And that's what leaves me with just 4x squared. But remember, whatever you do to one side, you got to do to the other. So that means they also added 16 on the other side. And that's why you get 16 on the expression to the right. So that is what they basically did. They added 16. So I'm going to put that into my notes. That's what I'm thinking. We just added 16 to both expressions. So which of these explains that in math language? Well, all right, let's eliminate. Let's pretend we don't really know our vocab too well. So the first one, it says distributive property, and I know this is not distributing. The next one says multiplication property. I didn't multiply, I added 16. So now we have the commutative property of addition and the addition property of equality. So I have to figure out, is it commutative or is it about equality? And this is where, for this one, this is absolutely about creating a balance. So I added to create balance. And where commutative, the reason that doesn't work, commuting would just mean if I switch the terms around. Like I commute to school, I go to school and back to school. So it would be like if I had 3 plus 4, I could also count it as 4 plus 3. Like I'm still adding the same numbers, but they can be in different orders. So that's what makes that one incorrect. Okay, but again, what you were looking for is that you added 16 of both. But why did you do it? Well, you did it so your equation would remain balanced. All right, let's hit pause and jot this down into our notes. All right, let's look at numbers 7 and 8. The answers are 4 and 2. Check off with your answers, and if you need to see explanation, we'll stay here. All right, we're going to start with the first one. What is an irrational number? And I'm going to give you like the 2-sentence quick, easy version of this. It means I can write it as a simple fraction or a ratio with 2 integers. So which one of these, when I simplify them, am I just going to have a fraction or a ratio with just 2 numbers? That's what I'm looking for. So we want something that is non-repeating. And if it is non-repeating, or if it goes on forever and ever, non-repeating or non-terminating, like forever, if you see these things happen, then I know it's going to be irrational. Okay? All right, so with the first one, you just have to kind of do them all together on your own. But with the first one, I see square root 3 times square root 3, which I could also write as square root 3 squared. And when I multiply that, I'm just going to end up with the answer 3. I can write that as a fraction, 3 over 1, so that's rational. With the second one, I'm just looking at it, and I'm going to add these 2 fractions together. And I'm absolutely going to end up with a rational number. Because some kids kind of have trouble with these, I kind of want to show you my way of adding without the calculator. So I'm going to I'm multiplying my denominators to get a common denominator of 12. And then I'm just going to multiply across. 3 times 1 is 3. Positive 3. And 4 times negative 2 is negative 8. Negative 8 plus 3 is going to give me negative 5. So negative 5/12, that is a fraction, simple fraction. It works. It's rational. With the next one, I have 5 times square root 81. I can absolutely find the square root of 81. That's just 9. And 5 times 9 is 45. Again, rational. And with the last one, if I were to add these up together, square root 3 doesn't have. I can't simplify that anymore. It definitely is not a square number. I can't do anything with this, so I'm only going to end up with 1/3 square root 3. This is my irrational. All right, let's look at number 8, which is a completing the square problem. So how do I know that? Well, because I know I'm looking at this format here, and I'm starting off with this, and I'm ending up in all of these cases with some type of binomial to the squared equals something else. That's what's telling me this is a completing the squares. So I want you to see how I literally complete the square here. So I'm going to start by just taking my numbers. And first I want to add 18 to both sides. Why? So I'm just left with x squared plus 6x is equal to 18. That's what I want. Now watch how I visualize x squared plus 6x. I'm going to start by making a square, and its dimensions are x by x. No clue what they are. Now I'm going to take my 3x, and I'm going to put 3 of them here. So I have 3 sets of x here, and 3 of them here. And so my job is to figure out what part is missing. So my job is to figure out what part is missing from that square. So one way to think about it is, how could I complete it? I could think, well, I have 3 groups of 3, which makes 9. So I needed to add 9 to complete this square. So I'm going to add 9 to both of my equations. And I'm going to end up with, in this case, I have 27 on this side. But guess what? I can write this x squared plus 6x plus 9, I can write that in another form. Look at your square. You have x plus 3 times x plus 3 gives you x squared plus 6x plus 9. So I can now rewrite this as x plus 3 squared is equal to 27. That's literally what you see in your picture. And that is why it matches number 2, and that is your correct answer. All right, I love completing the square. It's one that a lot of times teachers don't want to teach because it feels very different. It's hard. It's definitely harder to explain. But when you have a visual, it really helps. So hit pause and jot this down into your notes. And then I'm going to show you the traditional way your teachers will show it to you. All right, let's look at the answers for 7 and 8. We have 4 and 2. Check with your answers. If you have these, keep moving. If not, stay here for the breakdown. We'll start with number 7, which is asking which one of these will result in an irrational number. So what makes a number rational? Irrational, just real quick, what makes it rational? You can think of the word, you can make a ratio, or you can write it as a fraction. You can express that ratio as a fraction. What makes it irrational is if obviously you can't turn it to a ratio, and when you actually turn it to, if you try to use to represent it as a number, you will probably get a number with a decimal that doesn't repeat, so non-repeating, and it goes on forever like the Terminator. So non-terminating. That's what would make it irrational, and that's what we're looking for. So for the first one, we have a square root times a square root, which is kind of like we're saying the square root of 3 squared, which is the same way of saying 3. 3 is definitely a rational number. I can write it as 3 over 1. So we'll cross that one out. Number 2, I can work those numbers out. If you haven't done fractions for a while with adding, yes, you can use your calculator for this if you wanted to. That would be the quickest way. I just put 2/3 in parentheses like this. I know there's a way to represent it as a fraction. I just go kind of quickly. But I can do this, and I'm getting 0.416666 repeating. So even though they put a 7 at the end, it is a repeating decimal, which makes it irrational. Now, what I could also do with this, I could actually solve it out and get a fraction number. So my denominator is 12, 3, and 4 times -2 is -8, and that gives me -5 twelfths. Yep, that's fraction, nice and easy, so it's rational. For number 3, 5 times square root 81, I can simplify the square root. I can simplify the square root of 81 as 9, so 5 times 9 is 45. And obviously, through that process of elimination, we're going to get to 4. Y is for an irrational number. Well, I can't simplify square root 3, so I end up with 1/3 square root 3. And if you put that into a calculator, so 1/3 and then square root 3, you get this long a number that, again, you don't see a pattern in there. It doesn't end. It's going to keep going. And you can see that it is a non-repeating, non-terminating decimal. So, yep, that one is irrational. So you can use your calculator to confirm it, or as you're simplifying it, you can look and see that is definitely a number I can't represent as a ratio or a fraction. All right, the second one is, I like this one a lot. This one, if you're looking at it pretty carefully, this is actually completing the square problem, because every one of these solutions has a binomial squared. So we're going to complete the square for this. So I'm going to show you 2 ways to do this. One is the visual way that makes a ton of sense to me, and then the second one is the algebraic way, which makes a ton of sense to a lot of other people. So they both start the same way. Here's x squared plus 6x minus 18 equals 0. And the reason why we have to do completing the square for this is because when we're looking at the factors of 18, are you able to get to a positive 6? So that would be the first thing to consider. But also, when I look at this here, what I could do, like let's say you're trying to, I need my factors of negative 18. So I have 1 and 18, 2 and 9, and 3 and 6. None of these is going to give me a difference of 6. Like, it doesn't happen. There's not a difference of 6 between any of these. Here I'd have a difference of 17, difference of 7, difference of 3. None of them do. So what I'm going to do is I'm going to just add 18 to the other side, to both sides. And we're going to have x squared plus 6x is equal to 18. Now I'm going to complete the square. I'm going to show you visually what that looks like. I'm going to draw, here's my square, x over x. And I'm going to split the 3 in half. So I'm going to put 3 groups of x here and 3 groups of x here. And now your job is, what do I need to complete the square? And if you're looking at it, I have here 3 by 3 square. What does a 3 by 3 give you? 9. So I needed to add 9 to complete the square. And remember, whatever you add to one side, you're going to add to the other. So now that you have the side, obviously it's just 27. Now that you have this, what would that number be? Well, here's the other thing about it. You can literally see it on your square. I have x plus 3 times x plus 3. Which I can also represent as x plus 3 squared is equal to 27, which is 2. So that's how I use the visual for it. Now I'm going to show you the algebraic way as well, because a lot of times schools will say, you know, they may not teach it in this way. So pause and jot this one down to your notes. And what they're going to ask you to do is, I'm going to go back a little bit. To this step. And they're going to say to take the b, our second term, our b, which is a 6. Take that b and split it in half. And then you're going to square it. So what does that mean? You're going to take that b, that 6, and you're going to split it in half, which is what I did. I split the 3 in half to get, the 6 in half to get 3 and 3. But most kids will go, okay, so 6 divided by 2 is 3. And then you're going to square it. And that will give you 9. So you will still get x squared plus 6x plus 9. And then you're going to do the same thing on the other side, 28 plus 9. So the steps don't really change. But the other thing I like about the visual is that now here you're still going to have to factor it and think of your factors for 9. What you're going to do, luckily it's not too many, 9 and 1, 3 and 3, and it's usually that square number, that 3 and 3. Because that's what we're looking for to complete the square. So that's your hint. That's probably going to be, you're going to think of the square roots of the number. All right, and that's it for this one. Think about which one makes sense. For me, the visual makes a ton of sense. It's much more intuitive than the algebraic way. But if you're taught the algebraic way and it makes sense to you, you can use that as well. Hit pause and jot these two down into your notes. Let's look at number 9. We have a box and whisker plot. The answer is 3. Stay here if you need a breakdown, and let's jump right in. So what are the important parts for a box and whisker plot? Most kids are automatically just going to use their calculators for this. So let's make sure you know what the key information is. The box and whisker plot is pretty much giving you first your range of numbers. So it's giving you the smallest number, your minimum value, and your maximum value. And then in terms of the box, it's giving you, it's almost like if I were to complete this whole box, let's say this was, I turn it into squares like this, you would see that I have 4 parts to this box. Kind of like 4 quarters of the box. So the first section ends at Q1. Here's our Q2. here's our Q3, and here's our Q4, like the end of a quarter, like the end of the basketball game when it finishes into 4 parts. So I kind of think of it like that. But we also call our Q2 the median, because that's the way these numbers are arranged. We're not looking for a mean, an average in the middle. Instead, in the middle, we're ordering the numbers, and the very, very middle number is our median. The other thing that might come up with this is they might ask you for the interquartile range. And remember, range is like from minimum to maximum, but interquartile means from Q1 to Q3. How big is that? So if they ask you about that, you would just take Q3 and subtract Q1. All right, so that's the key stuff. Now, how am I going to use this on a calculator? So on a calculator, you're going to put in your data, and you're going to try and get these numbers. You want your minimum, it's going to give you your Q1. Instead of Q2, it's going to say median, Q3, and then instead of Q4, it's going to say maximum. Those are the numbers you want using your calculator, and then you can draw it out, and we're going to identify it. So we're going to go to, let's go to our calculators. We're going to go to stat, and then hit, because this is a statistics problem, obviously we're going to go to edit. And in L1, I'm just going to put those numbers, and they don't have to be in order. If I was doing it on paper, I put them in order. But being that we're using a calculator, I just have to enter every single one. Okay, so I have 8 values there, so we're good. All right, now you're going to hit stat again, and we're going to calculate the list. So calculate. We want one variable statistics, so hit enter. And you're going to go down. Yep, I want my list 1. Go to calculate, enter, and you're going to scroll down. And those are the numbers you wanted, because it's giving you a whole bunch of stats on it. But the ones we want for box and whiskers are that minimum, which is 69. The Q1, which is 70. Our medium, 71.5. Our Q3, which is 75. And our max is 78. Now I can use just those numbers and look to see which one matches. So the first part I like to look at is obviously my minimum is 69. So looking at this, I'm looking here, and I notice these two are at 65. So that gets rid of number 1. And then we can go down to the next one and look to see which one has a Q1 of 70. Okay, so of the two I have left, this one's at 70 and this one's at 70, so we're good there. Now let's go to the median, and it's at 71.5. So if I'm looking here, notice this line is somewhere between 71 and 72, so that looks like it works. And whereas this one here is between 72 and 73. So this one's at 72.5, this one's at 71.5. So this is our answer. Another thing I do have, because it might come up as a question, like if you ever had to draw it out, you could actually just use these numbers and literally put them in. Here's your minimum maximum, 70, 71.5, 75, and you would have drawn a perfect box and whisker plot. And again, if you need the IQR, you would just take your Q3 and subtract your Q1. 75 minus 70, your IQR would be 5. Just want to throw that in there in case it comes up. All right, hit pause and jot this down into your notes. All right, let's look at number 10, and the answer for this one is 3. We have a ton of space, so we're going to jump right in. All we're looking for in this one is the average rate of change between the dollars between 100 and 350 books sold, which is our entire range. To be honest, all our numbers are going from 100 to 300. So we're going to find our rate of change, our change in Y over change in X. This is our X, this is our Y. So how is, let's start with our profits. How are they changing? They're going from 425 to 50, because remember again, I'm doing our y2 minus y1. So I'm going to do 425 minus 50, and that's going to give me 375. And then change in x, so I want x2 minus x1, or 350 and 100. 350 minus 100 gives me 250. So that's what we're going to put into our calculators, 375 over 250. And that gives us 1 5/10, or because we're talking about money here, $1.50. And that's why the answer is 3. Hit pause and jot this down into your notes. Let's look at numbers 11 and 12. 3 and 1. Check with your answers. If you need to break down, stay right here. We'll start with number 11, and we're starting off by trying to figure out what happens to our simple x squared if I want that function to go 4 units to the right. So I want it to go 4 to the right, and I want it to go down 3. So how do I do that? What's going to happen to x squared to make it happen? So one thing is to know, if you have your forms when they're like, you might have x plus h squared and then plus k. So this number here is going to tell you if you're going left or right. And if the number is a positive number, it's going to go to the left. If it's a negative number, it's going to go to the right. Which is weird, right? Because when we think of number lines, we see it the opposite, and the negative numbers are on the left and positive right. And I know that association is so super strong for a lot of us. But I'm just letting you know that when we see that this, if I see a plus a number like +3, then I know I'm moving to the left. If I see -3, I am moving to the right. All right, and then on the second one, this k over here, if we see a positive k, I'm going up. Oh, so this one actually works really well. I'm gonna just do it this way. Positive k, we're going up. Negative k, we're going down. So that one is pretty intuitive with the number. So now let's think about what we want to happen. We want it to go 4 to the right. So that means I need this to be a -4. My h has to be a -4. And I want it to go 3 down, so my k has to be -3. So this is what I'm going to look for in my function. I want h minus 4 squared minus 3. All right, and that's what matches with 3. Now, let's say you don't remember this, because a lot of people don't remember h minus x minus h squared, or plus h plus k. Guess what? A lot of people don't remember this. This is where, again, you can use your calculator, and what you can do is you can go to your y equals, and we'll just put in x squared. So just starting off, x squared. All right, and now what you could do is you could just try, I would try just 2 at a time just so I can see it. So I might put number 1 is, and just put in my x plus 4 squared. Make sure you move it to the side, plus 3. And then when you graph it, you can see, is that what you wanted to happen? Did it go the way we wanted, which was to go 4 to the right and down 3? No. No, it didn't. It's actually up. It went to the left and it went up. So if that was the case, then you can go back in here and you can just change these and put in the actual numbers you want. So if you had done that, you eventually you can try all of them. But when you tried this one and graphed it, you would see the blue is the original, and you can see that it's moved over to the right and it's gone down. So that would have matched your answer. So that's just another way. Again, I really struggle with these videos because I don't want this to be a trick for you. I really want you to understand what's happening to the function. and what patterns to see and notice. But at the same time, recognizing that this is the time of year where a lot of kids are watching these videos to practice and really study for 40 exam. So I like using this form. And if you get a question like this, know the first one is telling you left, right, and the second one is telling you up, down. Okay, and whether it's positive or negative, I've kind of drawn it there for you. Let's go to the next one, number 12, and this is the plumber problem, and we're trying to figure out what is the interpretation of the y-intercept in this function. So let's start by just looking at this here. I have P of H is equal to 45 plus 90H. I kind of want this in our standard form, just like kind of like our mx plus b type form, because this is what we're used to seeing. We're used to seeing y equals mx plus b, and we know that this is our y-intercept. So let's just write it in that way, and this is 90H plus 45. And when we do this on our when we were to graph this, our intercept means when x is 0. So at 0 hours, that's what a y-intercept means. At 0 hours, because we want x to equal 0. You're still paying $45. So which of these matches that? It would be at the very start when they just come to the house, because that's where we haven't done anything. It's like our x is equal to 0. So at 0 minutes, you still have to pay, or 0 hours, you still have to pay $45. That is our initial cost. And the other ones don't match because he's not being paid $45 an hour. That would be the rate. Here, our rate is $90 an hour. And in the second one, $90 just to come to the house, that can't be it, because that would mean at 0 minutes, that would make this the constant. And $90 per hour that he works, again, that's just a rate, which we know is true, but this is a true statement, but it's not the interpretation of a y-intercept. All right, hit pause and jot this down into your notes. Let's look at 13 and 14 and inequality. And I love these tables with percentages. All right, starting off, our answers are 4 and 3. Check off with your work and see how you did. If you got them, move to the next chapter. If not, we're going to break it down right here. With 13, we do have an inequality. So the first thing I want you to remember, because in the process you might forget, is that remember, if you divide by a negative number, your sign is going to swap. It's going to hit that Uno reverse. It's going to flip to the other side. And I'm telling you to just jot that down, because sometimes you get in the middle of the work and we forget. We start moving so fast we might forget this thing that we know how to do. All right, so let's start by writing down the inequality. And we're solving for m. So we solve it the same way we would any equation. First, I'm going to distribute on the right expression. So I get 6m plus 12, and I have 2m minus 4. And this is where you can make a decision, because we do need to make a zero pair. We want to isolate the m's. And you have a choice. You have m's on the left and the right of the equal sign. So you can either add 4 to both sides, or you can subtract 12 from both sides. And that's usually the first decision a lot of kids will have to make. And I will say that most kids will decide they would rather add 4 than subtract. Just something, a trend I noticed. If you decide to do the other way, that's fine too. If you do your algebra correctly, you're going to get the correct answer. So let's say you were part of the add 4 crowd, and now you have 2m is less than or equal to 6m plus 16. Now I need to have a zero pair with an m. So I'm going to subtract 6m here, and you still end up with a negative number. So negative 4m is less than or equal to 16. And now to isolate the m, I do need to divide by negative 4. So here's where that Uno reverse comes in. And I'm going to end up with m is, and this is where the flip happens, greater than or equal to negative 4. And there's our answer for number 3. So again, that's why I wrote this down almost like as a reminder, because we know it's the thing we're supposed to do, but your brain might be just going super fast with solving for m and forget that little step. All right, let's go to number 14, and here we have a table of information, but the way we read it really matters because we're trying to find a percent, and percent pretty much means part over the whole, a total. But we need to figure out what part they're talking about and what total group they're talking about. So in this problem, we want the percentage of students who chose Broadway. Here are all the students who chose Broadway, and how many of them were girls. So the girls who chose Broadway over all the kids who chose Broadway. That's what we're looking for here. So it's super, super specific. And it's very easy to make a mistake because you could have put it as out of all the kids in the entire table. I make that mistake sometimes. So that's why we want to make sure that we're slowing down our thinking and reading carefully. So great, the girls who chose Broadway, that's 68. Out of all the kids who chose Broadway, students who chose Broadway, that means boys and girls in this case. So I'm adding 78 plus 69. So sorry, 68 plus 79, and we get 147. So in our notes, you're going to get 68 over 147, and just divide that on your calculator, and you end up with 0.462 or 46.2%, because you just moved that decimal 2 times to the right to turn it to a percentage. And that is approximately closest to 46%. So 46.2 is very close to 46%. All right, hit pause and jot this down into your notes. Let's look at 15 and 16. We get 4 and 3. Check off with your work and stay here for the breakdown. So for 15, we're adding 2 square root 54 plus 2 square root 6. Now, just looking at it here, it's almost like combining like terms. I can't add them. They don't look the same. There's nothing I can do to combine them. However, I can find factors of 54 that are square numbers. And I can rewrite this as 2 square root of 9 times 6, which makes 54, plus 2 square root 6. Now, this is a number that I know is a squared number. So I know that that number is going to be 3. So 2 times 3 square root 6, or 6 square root 6, plus 2 square root 6. And now it's like combining like terms because I have these two parts as the same, and I get 8 square root 6. Now, if you're wondering, what does this look like? Why can't I don't I have actually an extra one? Like, how can I add? Why am I only adding the 6 and the 2? Why am I not adding the square root signs? Let's go to our calculator. Now that I have the calculator on the side, I'm going to start by just putting 8 square root 6 so we can see its value, its exact value for calculator. And now I'm going to put the 2 square root 54, move to the right, plus 2 square root 6. And you can see they both have the same value. So yes, you are adding the 6 and the 2 together, and it's like combining like terms because they both have that square root 2. They have the same value of 8 square root 6, which is 4. Okay, so you are only adding these two whole numbers together and leaving the square root 6 alone. Now, for number 16, I'm going to keep the calculator here because there are 2 pathways to this one. One is you can do it algebraically, which is probably for some kids may feel like the longer one, and the second one is to just do it with a graph. So if you were just doing it for a graph, again, you're looking for the solution, which means where are these two graphs, where are the roots exactly the same. So I can just go to my y equals, and let me clear what I had here, and I can just put in my equations: x squared minus 5x minus 14. And on our second one, we have x plus 2. And I can graph them, and I'm looking for where they intersect. So, and you can just hit your trace button. Actually, I want to look at it on a table instead. So I'm going to hit second and table, and you can look to see where do they both have the same value. So where, when x is the same number, I get the same y's. And you'll see it happening, let's see, here at 8, where when x is 8, y1 and y2 are 10. And you can go in the opposite direction, because, and that's a little trick, sometimes you don't see it. If you want to see your negative numbers, you can just tap up, and you can see over here at -2, 0 and 0. So we can see it on the graph, at least for one of them. We can see that first intersection, but it was really hard to see the second one. Now, let's say you wanted to do it algebraically. So for this one, let's get rid of the calculator for a second. Okay, so we can set these two as equal to each other. So I can just put the equation x squared minus 5x minus 14 is equal to x plus 2. And now we want to set it to 0 so we can solve it. So I'm going to subtract the x, and I'm going to subtract 2. So I have now x squared minus 6x minus 16 is equal to 0. Now I can just factorize this. So I'm going to find the factors of -16 that add up to -6. That's going to be our goal. They have to have a difference of -6. So I have 1, 16, 2, 8, 4, and 4. All right, so I'm looking, I know one of them is going to be negative, so when I combine them, I want a -6. Well, I can combine these two, and as long as I have -8, 2 plus -8 is going to give us -6. So that's going to give us x plus 2 times x minus 8 is equal to 0. Awesome. Now you can set each of these to 0. So x is equal to -2 and x is equal to +8. So that's two ways you can solve this. One is using your graphing calculator, or two, you can just do it algebraically. Use the method that makes the most sense to you. Hit pause and jot this down into your notes. Let's look at numbers 17 and 18. We get 4 and 1. All right, stay here if you need it broken down. With the first one, we're looking for the product of which polynomial is equivalent to the product of x and y. So in other words, if I were to multiply this expression and this expression, what would I get? So the best way I would see to multiply it is to literally use an array method. So 4a squared minus a plus 3. And on the other side, I have a and minus 5. And now I can put my numbers in there. So I have here 4a to the third power minus a squared plus 3a. I'm just multiplying my a, and on the bottom, our bottom column, I get -20a squared plus 5a minus 15. And now I can add all of these together. Now the great part is you can either list all of them and combine like terms linearly. So what I mean is you can literally just write what's in every box and then put the things together. What I like to do is kind of just identify my like terms early. Like these are like, and they're always going to be diagonal, which makes it easier. And these are going to be, I'm going to combine those. So my answer is going to be 4a to the third power. -20a minus another a is -21a squared. 5 plus 3 is 8. So I'm just adding my coefficients. Minus 15, and that matches perfectly with number 4. All right, so I find that to be the easiest way. Some people want to use a FOIL-like way. I just find there's a ton of room for mistakes when we do this, where this method looks very clean and easy. With the next one, I gave myself a little bit more room, is we want to find an equation that passes through the line, that passes through point 37 and has a slope of 2. Problem is that none of these equations are written in our usual y equals mx plus b form. That's the first part of it. So what you could do for each of these is you could just rewrite them in that form. So in this case, I know I'm going to have to add 7. So I'm going to get, before I even add 7, I'm going to distribute. And then have to add 7. So I'm going to get y is equal to 2x plus 1. For 2, I'm going to get, let's see, y minus 3 is equal, I'm just going to distribute. And now I'm going to add 3 to both. And so I can get y is equal to 2x minus 11. Let's do number 3. Y plus 7 is equal to 2x plus 6. I'm subtracting 7 on the side, so y is equal to 2x minus 1. And 4, y plus 3 is equal to 2x plus 14. And this time I'm subtracting 3. So y is equal to 2x plus 11. Okay. So now that at least I have that, that's going to make it easier because now I can write my equation. So I wanted it into y equals mx. Oops, didn't make an x. Plus b form. They're telling us that the slope is 2. So I know it's going to be y is equal to 2x plus b. And now they're going to give us, how do I know what that b is? We're going to substitute the 3 and the 7. So 7 is equal to 2 times 3 plus b. This way we can solve for b. So 7 is equal to 6 plus b. That means b has to equal 1. Because 6 plus 1 is equal to 7. So now I can write my equation y is equal to 2x plus 1 and look to see which one matches that. 2x plus 1 was the first one. So our answer is 1. So you can kind of see like there are some different levels of complexity with these problems. It just means that you do have to use multiple skills to solve them. And it can look really overwhelming in the beginning. But again, keeping calm and relying on your skills is the best way. Like a lot of people want to say you'll rise to the moment when in reality, we fall back to our skills and training. So if you've been doing your skill and training in math class, calm yourself down. You know the mathematics in order to do this. And if not, that's why you're watching this video, so I can help you figure out what skills, because I guarantee you have many of them in you. But if you're nervous, you will forget what to do, because that's what logically our mind does. Okay, so don't get overwhelmed by this. We know the standard form is y equals mx plus b. They gave us a point and they gave us a slope, so we are able to fill it out. Hit pause and jot this down into your notes. Let's jump into 19. It's a geometric sequence of a ratio of -3. So what does that mean? It means that we're going to multiply times -3. We're going to be multiplying by -3 to make the pattern. And the answer for this one is 4. So what you would be looking for, let's say I was looking at number 1, and I'm going to have the numbers here. I would look to see is, if I were to multiply by -3, 10 times -3 does not give us -7. So no, that wouldn't work. And that's kind of what we're looking for. But when we looked at number 4, so starting with 4, if you multiplied it times -3, you get -12. If you multiplied it by times -3, you would get +13. 36. If you multiply this by negative 3, you will get negative 108. So that's all the common ratio is. When it's a ratio, we're multiplying to create a pattern. In this case, we're multiplying by negative 3. Hit pause and jot this down into your notes. Okay, let's look at 20 and 21. The answers are 2 and 3. All right, we're going to start with number 20. We have an equation and we want to solve for x in terms of a. So pretty much the main part you have to know is that you're going to solve for x. That's it. And we're not going to know what a is, and that's okay. That I find is the hardest part for a lot of kids to accept. So I'm going to just solve. Okay, so I'm going to, in this case, let's add 8x. Because again, most of us would rather add than subtract. And that's going to leave me with 6 is equal to 2ax minus 2. And now I'm going to add 2 to both sides. And I'm going to end up with 8 is equal to 2ax. Now, I want the x by itself. So I'm going to divide by 2a. And divide by 2a. And that is going to leave me with, let me move it to this side, 8 over 2a is equal to x. And I can simplify this. 8 divided by 2, that would make it 4 over 1a, or just 4 over a. Because all I did was simplify, divided 8 divided by 2. That's it. And so this is the answer I'm looking for. 4 over a is equal to x. And there's 4 over a. And again, we're solving for x, so that would have been equal to x. So the answer was 2. Next one, number 21, we're looking for solutions. We want to find a function that has the zeros at negative 1, 3, and negative 4. So here's the cool thing about this. So if you recognize the pattern, because you know that you've seen it, like if you had this, then you know that the solution for this one is going to be x is equal to negative 5. Why? Because you know you're going to do x plus 5 is equal to 0, and then you're going to isolate by subtracting 5 on both sides. So x is equal to negative 5. That's kind of the math pattern you'll probably see. So in this case, in order to have the solution, x is equal to negative 1, x is equal to positive 3, and x is equal to negative 4, you know that you're going to set this up in the opposite way. This would have been x plus 4 is equal to 0. So set these up equal to 0. So here I know in the second one, I'm going to have to subtract 3 on both sides. X minus 3 is equal to 0. And on the top one, x plus 1 is equal to 0. So now that I have this, you could figure out, okay, my answer is x plus 1 times x minus 3 times x plus 4. And that would have given us 3. That is one way you can solve this. So hit pause for a minute and jot this down. And now I'm going to give you the other way. Let's say that you didn't see that pattern, or you just don't feel confident in that pattern. Like this, it looks like it makes sense, but it feels like too much of a trick. And sometimes when our mind can't make sense of it, we don't accept it. So let's say you can't accept this. You're going, Sarah, I don't want to use that. That's okay. Then in this case, you would just, oops, sorry, didn't want to erase everything. You would just go by each one and you can just solve for x. So for example, I would just take the first one and I have x plus 1, x minus 3, and x minus 4, and you can set them all to 0. And check to see which one matches what you wanted. So does this match? Well, this part matches as a solution. This part matches as a solution, but not this one. So that would mean one doesn't work. I'm going to do one more so you can see it. Like, let's say I would have picked a third one, which we know is the correct answer. So this one has x plus 1 times x minus 3 times x plus 4. So I would have done the same thing. X plus 1 equals 0. And we're going to subtract 1 on both sides. X minus 3 equals 0. I'm going to add 3 to both sides. And x plus 4 equals 0. Subtract 4 from both sides. And then you would just go back and double check with your work. X is equal to negative 1, x is equal to negative 1, x is equal to 3, x is equal to 3, x is equal to negative 4, x is equal to negative 4. So now you have 2 ways that you can solve this problem. Hit pause and jot this down into your notes. Almost done with multiple choice, 3 more to go. So let's look at 22 and 23. The answers are 2 and 3. Check with your answers and stay on if you need the full breakdown. So when I first saw this problem, I tried to think for a second, how would I get as a final answer 5a plus 2b? And this is one where you're going to have to think backwards. And how would I have gotten that solution? There are 2 power rules that would have come in. So the first one is try and think where you have, for example, a to the b power times a to the c power, and that would give you that a b plus c, because that's the first thing I'm looking for, is what rule gives me this type of solution in my exponent. And the only way I would have that is if I have 2 numbers being multiplied but they have the same base and different exponents. So that's the first part to think about. All right, so what would that look like? That would kind of mean I can have 5a times 2b, because that would have given me 5, same base, a plus 2b. Great, but now I have to think a little bit more. What would happen for this one here? And this is where that second rule kind of comes into play. And think back to when you see an exponent being multiplied by another exponent. So when you would see this, and you see exponent out the outside of the parentheses, you would end up getting a, and that's where b and c are being multiplied together. Because again, I'm looking for a rule. When does this happen? Where I would have 2 exponents being multiplied together. Well, you'd have one base, and then those 2 things happening. So I don't care about the first part. The 5a stays as is. But that means for the second one, I probably have 5 to the second and then to the b. Because this part here would give me that second part I want, which is that 5 2b. Okay, so that's what we're seeing that one. And that's one where if we see this here, now we can simplify this 5 to the a times 25 to the b. And that matches 2. So this one was an interesting problem because it meant a ton of working backwards and trying to remember when did we see this when we were doing exponents. And the first thing I thought of is, well, when do we see 2 exponents being added? And we know when it's the same base and 2 different exponents. And then when do we see 2 exponents being multiplied together? And we know that only happens when we have the same base and then exponent times an exponent on the outside of the parentheses. All right, let's look at the next one. 23 is actually deceptively easy. We're looking for an arithmetic sequence, meaning I'm adding, and I have my first term and my third term. So this is a blessing where they're giving us the first numbers for, they don't give us the second number, but they're giving us the third term is -2. And we know that we're adding to get to them. So it's going to be a constant difference. So, and we just have to figure out what number they skipped. All right, so that's the pattern. We're adding or subtracting the same number again and again. So since they skipped a number in the middle, try and think, how would I get from 4 to -2? Well, I would have had to go down 6. So then now I try and think, well, then what's the halfway point? If I know all of this plus this has to be -6, I'm just going to half that. So that means I will do -3 and then another -3. And that gives me 4 minus 3 gives me 1. And 1 minus 3 gives me my negative 2. Okay? So that's all I did. I know that the difference between my first and third term is negative 6. I split it, so I have minus 3 and minus 3. And then if I did 4 minus 3, I got 1. And then 1 minus 3, I get negative 2. So that is our common difference. Hit pause and jot this down into your notes. Here's our last multiple choice problem, number 24. So after this one, you can add up all your multiple choice correct answers, and each correct answer is worth 2 points. So our answer for number 24 is 4. Check off. And if you got this one correct and you feel great with dimensional analysis, just move to constructive response. If not, stay where you are. So there's a ton of information in this problem. They're telling us about gallons and feet, and how many gallons are in a truckload of water, all this information. What they're basically asking us is which expression will allow Joe to calculate the number of truckloads of water he needs to fill his pool. So I am looking for which of these gives me how many trucks, the truckloads of water per pool. Okay, trucks of water over pool. So what you can do is now you can start canceling out with your dimensional analysis. And what I mean by that is if you see the same unit in the numerator and denominator, we can cancel them out together. So if I had something like 4 feet in 3 seconds, and then something like 360 seconds per 1 minute, because I see seconds in numerator and denominator, these would cancel out. Why? Because in my final answer, I would have feet times second and over seconds times minute. And so these two would cancel out. It would be dividing by itself, a second divided by a second. And I would end up with feet per minute, which is what we see here. So that's kind of the same way I'm going to approach this, where I want trucks of water to pools of water. All right, so let's look in there, and we're going to start looking again for which units are in the numerator and the denominator. And so in the first one, I do see gallons here and here. So these cancel out, but not everything else. So in my final answer, I would have cubic feet times cubic feet over what's in the pool times the truck. That's not what I want. We're going to cross it out. And then the second one, do you see anything that can cancel out? In this case, no, because again, you're looking for what units are on the same on the top and bottom, or numerator and denominator. Here, feet are both numerators, gallons are both denominators, and we have pools and trucks. So I'm going to end up with feet cubed squared times what's truckload of water over gallons squared times pool. That's not what I'm looking for either. So we're going to cross that out. All right, let's look at number 3. Look carefully. You'll see feet in our numerator and denominator, but nothing else cancels out. So I'm going to end up with my answers in gallons squared over pool times truck. So that one doesn't work. And in the third one, you'll see cubic feet, and gallons. This one looks super promising, and does, the only one that's left, so it should be. So here I'm going to end up with my truckload of water over the pool. So 4 is my correct answer. And again, they're not asking you to solve it, so I don't really have to do 3,240 times 7.5 over 6,000. I don't have to do all that. They just want to know which expression would allow me to get that answer. And there you go. So that's what you're looking for in dimensional analysis. You're looking to see how can we simplify by finding units in the numerator and the denominator. Hit pause and jot this down into your notes, and we're going to move into the constructive response. All All right, let's look at our first one. We have to graph this function. So the easiest way to do this is actually using your graphing calculator. So for our solution for this, we do want the minimum, which means the lowest value, and in this case it is going to be -2, 3, that point. So on your calculators, you're going to go to your y equals, and you're going to just put in your formula, x squared. We're put in this function plus 4x plus 1. And so this is the graph we're going to draw. And if you try to draw it this way, yes, you can see some of the points, but it's not exact. Like some people might put a point at 0.00, which would be incorrect. So to be super careful, why don't we hit second and graph and get to the table. And now we have some points that you can actually graph. And I have those points there. And so I just chose a few of them, and I can see what my lowest point is. And obviously we're here, I went and found some more points on the positive and negative side because I wanted to know what the lowest one was, and it was at -2, -3. So right there, my y was this lowest at -3. So once I had a few points, I just graphed it and put it all together. So again, easiest way to do it. And as I was saying on the graphing calculator, if you want to see more of the points in the negative value, just make sure you're moving up, because you'll probably start at when x equals 0. But if you want values where x is less than 0, you can continue to shift up. And again, we're looking for the lowest y value, which was right here at 2, -3, and that's what we've highlighted. This is our minimum value. All right, hit pause and jot this down into your notes. Here's our next 2-point question. And again, they're not just looking for an answer, they're looking for your work that demonstrates how you got your answer to show understanding. So for this one, your answer, f of 1/2 is equal to 3. So how do we start from there? All right, in the beginning, I always start by just jotting down my equation, and this is what we're trying to figure out. So when x is equal to 1/2, what do we get? So you're going to start by just thinking when f is equal to 1/2, and you're going to start putting in those values. So 30 times, well, instead of x squared, it's 1/2 squared over 1/2 plus 2. So I'm just substituting here for x. And now this is where we're just doing algebra work and working it through. So 1/2 times 1/2 is 1/4. So 30 times 1/4 over 2.5. Simple enough. So now I'm just going to multiply 30 times 1/4, and I get 30 over 4 over 2.5. So this is a nice complex fraction, which maybe you haven't seen since 7th grade. And that's okay. So one thing you could do is you can just simplify at least the top part. 30 over 4 is the same thing as 7.5. And then the 2.5 just stays. And we could rewrite this as a division problem. 7.5, which I always say, all right, 7.5 divided by 2.5, and that equals 3. And you can use your calculator for any of those, but that's how you get your final solution 3. The key to this is just substituting and doing strong math work. Now, could you use your calculator for this? Yes, but again, if you're using your calculator for any simplification, use it simple at a time. If you just went and substituted everything in a calculator and just put the answer, it doesn't show you know how to do it. But if, let's say, you use the calculator to do this section, that's fine, but then simplify by rewriting it and showing the 1/4. So that's one way to think about it. The same way, if you're not sure how to turn 7.5 into a fraction, you could just put 1 divided by 2 and you'll get the 7.5. And again, if you want to do this part, that's fine in calculator. Just make sure you're writing the full expression. So now look at your work and give yourself either a 0, 1, or 2. A 0 if you had no answer or just a completely off base answer and your work doesn't show you knew how to do it. A 2 if you got the full answer, f of 1/2 is equal to 3, and your work shows how you got there. And a 1 if your work kind of shows how you got there, or if you were doing the right steps but you made a calculation error somewhere along the way. Score yourselves and write it down in your paper. All right, let's look at number 27, another 2-point question. And this one is just a lot of explaining. They want to see that you understand how to recognize if you have a function or not. So in looking at this one, I'm looking at my x values as the input to output and noticing for every x value, I only get one y value. Okay, there's a unique y value for each one. So because of that, I can write down my answer as one output y for every input x. Or for every value x, there is only one y. So either of those, you just have to make it make sense in your sentence. In the second part, they're saying that this new table will not be a function, meaning you're probably going to have more than one output, more than one y for an x somewhere. So looking here, we can see that each of those x's has one y, so it must be that missing number. And so I just made up a number because it says you can complete the table, and I just decided to pick 2 because I'm just repeating when x equals 2, but I'm giving it a different answer. So now I'm giving it 8. So now I have 2 different answers. When x equals 2, I can have 5 or 8. That is not a function. But you could have used any number, but you had to repeat the x's. So it had to either be a -1, a 0, a 1, or a 2. But then for your y value, it could have been anything, as long as you're using the same x on top. So here's my reasoning why it is not a function, because input 2 has 2 outputs, 5 and 8. All right, or here's another way. When x equals 2, there are 2 outputs. Y equals 5 and y equals 8. So again, that makes it not a function. So give yourself again a score of 0, 1, or 2 for your explanations on both. So if you had 2 great explanations, perfect, 2 out of 2. If you had 1 good explanation, or you didn't fill out the table correctly, you probably lost a point somewhere. And if you were completely off base, you would give yourself a 0. Score yourselves, write it on the paper, and we'll move on to the next problem. All right, now we're going to do some algebra number 28, and I'm going to put a line down the middle because I'm going to show you there's one method that goes a little bit faster than the second one. Sometimes we get really caught up in rules in math, and especially when we see these, we get very caught up in order of operations and let's distribute first. But I'm going to just imagine, and you can decide afterwards which one you'd rather do. What if, I'm going to put this here, I decided not to distribute. And what I mean by that is, here I have x minus 3 times 0.05 or 500. So instead of distributing, which I can do, what if I just divide by 0.05 here and 0.05 here. Now, why that matters, I'm going to show you in a second. What is the benefit is what I want you to think about. So on the left side, I know these are going to cancel out, and I'm going to be left with x minus 3 is equal to 0.05x divided by, oops, sorry, not 0.35x divided by 0.05 and 7.5 divided by 0.05. And now with my calculator, I can just do 0.35 divided by 0.05 and I get 7. So x minus 3 is equal to 7x minus 7.5 divided by 0.05 and I get 150. I want you to think about how simple this looks right now. And now I can just solve for x. In this case, which one do I want to do? Let's add 3 to both sides. That tends to be my default, is to add. This is 147 and subtract 7x on both sides. So 1x minus 7x. So if I had $1 and I owed $7, I can pay $1, but I still owe $6. And divide by negative 6. 147 divided by 6, and I get 24 5/10. That's method 1. That works very, very well. Let's say you decided to distribute though instead. You're going to get the same answer, but I want you to think again about what could happen. So if I were to distribute, I would get 0.05x minus 3 times 0.05, 0.15 is equal to 0.35x minus 7.5. And now I still have to go and make decisions. Now automatically I have a ton of decimals here, and this is where I think a lot of kids end up making mistakes. And it's just more room for error. So here I have 0.05x is equal to 0.35x, and I will still use, and again, let's clear this out for a minute, and I'm going to make negative 7.5 plus 0.15, and this is the point where I can see a lot of kids making a mistake. Just that right there, where I'm adding positive and negative integers together. And now I can subtract. And this is a second point where I can see kids making a mistake. So 0.30x, or 3/10, is equal to negative 7.35, and then dividing by 0.30. And you still get your answer. Oh, forgot here, this was a negative number, so I'm dividing by a negative on the other side. Make sure you have that, because that was, again, there's so many small places to make errors here. So negative 24 and a half, or a negative divided by a negative makes this positive 24 and a half. So I think it kind of just proves my point that there's just so much room for error in this problem. That's how this problem is designed, because they're looking for consistency with how you're adding and subtracting with positive and negative values. Consistency, or you're being precise when you multiply with positive and negative values. And even you just saw me right now forget that this was a negative sign here, so I was dividing by a negative. And then when I made that mistake up, I forgot that I was dividing here and had a positive answer. There was just a lot of room for error. So in cases like this where you might see, obviously I'm getting the same answer in both, and they're looking for that level of understanding and care. So yes, you can use your calculators for these. It's not doing all your work, but notice how I'm using it as a tool and making sure I show that as I'm simplifying my expressions. That's one. But there are also places like this where, if you notice, you have a term being multiplied by another set of terms. I could just divide both expressions by this here to simplify it, so that I'm just left with the x minus 3. So it's just food for thought. Again, you can choose and decide which one you want to do. Now, you're going to go off and give yourself, again, a score of 0, 1, 2. 2, perfect answer and perfect work that shows all your steps with no errors. If you had an error somewhere, subtract a point. If you had multiple errors, you might have 0 points. All right, hit pause and score yourself and write it down in your work. Okay, with 29, they are once again looking to see, can you actually use a quadratic formula? This is pretty typical for an Algebra 1 Regents, but you have to use the quadratic formula for this. So I'm going to put the final answer in there and actually show you the full work. So I'm starting off with this equation, x squared plus 3x minus 6 is equal to 0. And I like to start by just recognizing my A, B, and C terms. So again, here's our A, here's our B, here's our C, because we have ax squared plus bx plus c form. And now with that, I know my A is equal to 1, my B is positive 3, and my C is negative 6. So your final answer should be x is equal to negative 3 plus or minus square root 33 over 2. So you can have this as your final answer and leave it there. So how do we show that to get full credit? Well, first I like to write down my quadratic formula to make sure we have it. Because again, the goal is to demonstrate we know how to use a quadratic formula. So let's start by writing the quadratic formula. So x is equal to negative b plus or minus square roots of b squared minus 4ac over 2a. And now I'm using these over here and just plugging it in. So I end up with negative 3 because my b is a positive, so negative 3 plus or minus the square root of 3 squared minus 4 times 1 times negative 6 over 2 times 1. And now I can simplify this further, and I get negative 3 plus or minus the square root of 9 plus 24. Okay, so all I did was multiply negative 4 times 1 times negative 6, and I get positive 24 over 2. And I simplified it even more. 3 plus or minus the square root of 33 over 2. And that's it. I can leave it there. There's no other way for me to simplify. So I'm just going to put our x equals, and this is my final answer. And that's it. They just want to see that you knew what the formula was, which I showed, and that you were able to substitute. So they're going to look for the subs, the Q formula, the quad formula, and they just want to see that you can simplify it. That's it. Alright, so now look at your work and score yourself on a 0, 1, 2. Give yourself 2 points if you substituted correctly and you simplified it correctly and got the exact correct answer. Give yourself 1 point if you made an error somewhere, like it could have been for positive and negative, and give yourself 0 points if you left a blank or you were wildly off base. Hit pause, score yourselves, and jot it down on the page. Alright, let's jump into number 30, which is a factoring problem. I like this one for a 2 point. So I'm going to start by just writing 5x to the third minus 80x. And you're looking to see, do they have any common factor? So is there anything I can take from here and from here? And I noticed that, well, just with 5 and 80, they do have a common factor, 5. And also looking at my coefficient x and x, I can factor out an x. So I can do that. So I'm going to rewrite that as I'm going to put the 5x on the outside. And here I end up with x squared minus, and this for 80 divided by 5 is 16. And my x's go away. Okay, so I have 5x times 5x squared minus 16. And I noticed something. I have perfect squares. So I'm going to use my dots method for this one because x squared is a perfect square and 16 is a perfect square. So I can rewrite this as x plus 4 and x minus 4. So I can put this in here. And there you have it, because x squared is x times x, and 16 is 4 times 4, or negative 16 is a positive 4 and a negative 4. So I can have this as my final answer. Hit pause and jot this down into your notes. Let's look at number 31. This is our first 4-point problem. It's a linear regression problem, and we're looking for some type of relationship between the temperature and the ice cream sales. So is there a relationship either positive or negative? Like when one goes up, does the other one go up? And we can suggest that's true. When the temperature goes up, the amount of ice cream goes up. or maybe one goes up, the other one goes down, and how strong that correlation is. If there's a strong correlation, they are strongly connected to each other. If there is a weak correlation, meaning they don't impact each other very strongly at all. So what we're going to do, this one, you do need your calculator. So first thing you're going to do is you're going to go to mode, and I want you to go down to where it says stat diagnostic, and just make sure, oops, I passed it, that it is hit to on. So make sure that is there, and then you can clear out. That's the first thing you're going to do. Now you're going to go to hit stat, and we want to go to one edit, and we're going to list those numbers. So we have our X values for temperature. So 72, 75, 81, 78, 77, 76, and 80. So I have 7 values. Let me just triple check. 1, 2, 3, 4, 5, 6, 7. Awesome. And now I want to go to the other side, and I'm going to put in, oops, 126, the ice cream sales. Okay, so everything is there. So we have all our data, so we're going to hit stat one more time. And I'm going to move over from edit to calculate. And I'm going to go down to linear regression. You'll see it, number 4, L reg, that's linear regression. And you're going to hit enter. And we want, yep, that list 1, that list 2. We're going to go down to calculate and hit enter. And this is all the information we want. So in the first one, they're going to ask us state the linear regression equation. So I'm just going to copy the form I want is ax plus b, and I have right there my a and my b. So I'm going to put those in. So y is equal to, so for a, I'm going to put 15 up. It wants it to the nearest hundredth. So 15.13, I'm going to round it up to 3 because I have a 5 there, x, and then I'm going to put in my b, which is actually a negative number, negative 959.63. Okay, so that's all I need to do is I need it, and if you get stuck with it, you can kind of just write it down and just use this to help you. If need be, to help you with the rounding. But that's all they're looking for in the first part, is can you get that? All right, and then in the second part, they want you to state the coefficient, and that is your R. And we have that also to the nearest hundredth. So we have our R is 0.9917. So we're going to round it. And look at the buddy over here. It is a 1. So we're going to round it to 0.99. Okay, so that way they can see what our real answer is. So we have that there and there. And now we have to say whether or not this correlation coefficient, in the case of, what does it say about the line of fit? Is it strong or not? So this is kind of the way we think about it on a strong line. It's a line going from -1 to 1. And if it's very close to 1 or very close to -1, it would be a strong correlation. Okay? So if it's over here, close to here, it will be a strong negative correlation. If it's close to here, it will be a strong positive correlation. Now our R, in this case, 0.099 is very close. Very, very close to 1, which suggests a strong positive correlation. And that's it. That's all they're asking. They're not asking for any justification. They just want to know, is there a correlation, and how strong is it? And I'm using my R to tell me that, because it's very close to positive 1, is a strong positive correlation. If this was a negative 0.99, then it would be a strong negative correlation. If it's somewhere around 0, then it is a weak correlation. All right, and that is it for this one. So score yourself on a 0 to 4. Typically, you can kind of think of it as 1, 2, 3, and 4 to give yourself some points. As long as you don't have any errors there, you would have a perfect 4. And again, you do need your calculator to do this. Hit pause, score yourself, and jot it down on your notes. Okay, let's look at 32. We're going to graph a system of inequalities, and we're going to look to see where the solution set is. In other words, where our two inequalities kind of overlap. So I like putting things in being able to graph by hand, but you could use your graphing calculator if you want it. But I'm going to start with the very first one. And we're going to graph y is greater than 3x plus 4. And I like that because since I already know my slope is positive 3, and I see b is equal to 0, negative 4. So that's my y-intercept. So I'm just going to start with that. 1, 2, 3, 4. So here is 0, negative 4. And since my slope is positive 3, I'm just going up 1 over 3. I'm sorry, up 3 over 1. 1, 2, 3 over 1. Up 3 over 1. And there we go. So I have this part. Now, how do I draw the line? Because this is it's y is greater than, it's not underlined, it's not equal to. So I'm just going to make dashes through these points. Okay? And because y is greater, that means I want all of these. Everything up here on the line. And this is my line, y is greater than 3x minus 4. Okay, so the second one, and I'm going to do the second one in a totally different color. Here's my problem with the second one. It's not written in an easy form for me, so let's rewrite that. So I have x plus 2y is less than or equal to 6. So I'm going to move the x over to get 2y is greater than or equal to negative x plus 6. And now I have to divide everything by 2. And that's going to give me y is less than or equal to negative, instead of x over 2, I'm going to put negative 1/2 x. And then 6 over 2 is 3, plus 3. Okay, so I have my m is negative 1/2, and my b is equal to 0.3. So let's start by, here's my intercept, and now my slope is to go down 1 over 2. So down 1 over 2, so they overlap right there. Down 1 over 2. And because this one, and I'm doing the opposite, going up 1 over 2 in the other direction. And because this one is less than or equal to this line, I can connect. So here's my y is less than or equal to negative 1/2 x plus 3, or my x plus 2y is greater than or equal to 6. Okay, so I do see that this point here looks like it could be a solution, but notice, remember, these are dashed on this line, so it can't be this line. For here, it doesn't fall on the line for here because it's dashed, but it does fall on the line. This little point does fall on it there. Okay, but I'm getting a little ahead of myself. Let's actually put in, it says that y is less than, so I'm going to go down the line. And so my solution is over here. This is where the two of them overlap. So that's the first part of this problem, is to be able to graph it correctly and to mark my solution. And I did that. I graphed both lines. I'll give you the equation for both. I made sure that I have dashes for just y is less than, and a straight and a complete line for y is y is greater than was dashed, y is less than or equal to was solid. All right, now for the second part, I need to say is point 2 a solution. That was the point I was talking about right here. Is this a solution? And obviously I can say there are two ways I can think about this. I can say it is a solution only for no. 2 is a solution only for the equation x plus 2y is greater than or equal to 6, but not y is greater to 3x minus 4. Now, part of it is, and this is where a lot of kids get have a challenge, is explaining, well, one is dashed and one is not, meaning it's not in the solution set, it's on the line. That can be very confusing. And how you explain it really matters. So what you could do is actually evaluate for the point to prove that. So you can substitute in equation y is greater than 3x minus 4 2 is not a solution. And I can say C work. And I can substitute it in 3x minus 4 and put 2 is greater than 3 times 2 minus 4, or 2 is greater than 6 minus 4. 2 is greater than 2, because 2 is greater than 2 is not a true statement. So 2 is not a solution to the system of inequalities. And I just kind of ran out of space there. Okay, so what I tried to prove in this one was, one, being able to say my answer no, and now I have to justify it, that it was a solution for one but not the other. I showed algebraically why that was not true, and that statement cannot be true. 2 cannot be greater than 2, therefore it is not a system of inequalities. All right, so that's what they're looking for in this one, and again, they're scoring your work as a 0, 1, 2, 3, 4 based on your graph, your graphing skills for inequalities, and for answering this question. So score yourself on a 0, 1, 2, 3, or 4. 4 is perfect work all over the page, great explanation, very clear, perfectly graphed, and examples are there. 0 means you had no idea, no clue, probably left a blank. If you had some type of error somewhere, depending on the number of errors, you might have a 1, 2, or 3. So trust yourself and try to evaluate where do you think you land on that scale. Jot that down on the page, and then we'll move on to the next problem. Okay, for number 33, which is another 4-point question, we have another situation with a parabola happening where we launch something in the air and it comes back down to the ground. This one you absolutely will need your calculator for. In this case, they give us S of t, they've given us the formula, and they want us to state the vertex of the problem. So we need to actually put this in. Let's graph it so we get a visual of it. So I'm just going to put it into our graph, and negative 16, don't worry about, you don't need a t, so I can use x, x squared plus 64t, 64x plus 80. And you can graph this, and of course you're going to get something like this at first, so you may have to really zoom out, and even there, like, you may have to find your zooming out again, and zooming out again, and you're like, oh my god, this takes forever. So don't worry if that happens. You can just hit second and go into your table, and here you can look for that vertex, like where your graph is going to change. And notice here, so time, this is where we want x to only be positive numbers. So we notice at 0 it's at 80 feet. That's where we're starting from, and then it gets a little higher to 128, and then it gets to 144, and then it goes back down. So here's our high point at 2 seconds, 144. So that's our point to 144. That's our vertex. That's where we see the change happening, where it drops. And that means at 2 seconds, the ball is 144 feet high. So now we have to do the second part and answer, after the object is launched, how many seconds does it take to hit the ground? So we want to know, and if you're looking at your graph here, your table, you can see that at 5 seconds, it goes down to 0. Y is at 0. So let's put that in. At 5 seconds, the ball hits the ground. Now it's also asking us to justify our answer. Like, how do we know that is true? So what I'm going to do, there are two ways you can kind of do this. One is you would just substitute and prove it's true, but I don't want to do that yet. I want to show I know how to get there. So I'm going to put in my equation first. So S of t is equal to negative 16t squared plus 64t plus 80. And actually I'm going to set this to 0, because that's what we want. We want when this is equal to 0. And we're going to start factoring out. First thing I want to do is I want to factor out 16 from all of these, because that is my common factor. I can divide all these numbers by 16. And if you weren't sure, you can actually test it with your calculator, but I'm going to take out the negative 16 on the outside, so that I'm left with t squared minus 4t minus 5 is equal to 0. And now I can use my factoring. And again, factors of 5 are pretty easy. We know it's just going to be 5 and 1. So we have 5 and 1. Since it's going to be a negative, the factors have to add up to negative 4. It's going to be negative 5 and positive 1. And so we can test all of these out. We know that this is not true. Negative 16 is not equal to 0. T minus 5 is equal to 0. So t is equal to positive 5. And t minus 1 is equal to 0. Or, sorry, t plus 1 is equal to 0. Or t is equal to negative 1, which invalid. We can't have time at negative 1. So that means t is equal to 5. And then you can sub in and show that it actually works. So you can actually do negative 16 times 5 squared plus 64 times 5 plus 80. You can show your work and actually test it out. And if you do a negative 16 times 25, because that's what you're working here, you'll get negative 400. Plus 64 times 5 is 320. Plus 80, I'm just going to add the 320 and the 80 together to get 400. And negative 400 plus 400 does give us 0. So yes, this makes it true. This is our check. And that's it for this one. So score yourself as a 0, 1, 2, 3, 4. Give yourself first check and see if you can contextualize what the vertex means and give that coordinate. Both of those things have to be true, and then prove when it hits the ground and actually demonstrate it in your answer. Score yourself on the 0 to 4, jot it down on the page, and we'll get ready for the next problem. All right, we're up to question 34, which I think is our last 4-point question. And here we want to solve the system of equations algebraically for x and y. All right, so pretty much that means since I have y equals and y equals, I'm going to set these two equations equal to each other. So I'm going to put, here's my first equation, y equals, and here's my second equation. So I'm just going to write x squared plus 4x minus 1 is equal to my second equation. Because they're both equal to y, I can do this. And now I'm going to try solving for x. So I'm going to subtract 2x from both of them because I really want to get a zero pair on the right side and just have 7. My goal is to turn this into a quadratic and set it equal to 0. So I now have x squared plus 2x minus 1 equals 7. So again, I'm going to subtract 7 from both sides because now I want to set it to 0, which I did. So we have x squared plus 2x minus 8 is equal to 0. So now we can do some factoring, and this is our usual where we know we're going to find the factors of -8. And so we know we have 1 and 8 and 2 and 4. And if I wanted my sum to be 2 with those factors. So I'm going to use the -2 and the 4 and the positive 4. That's what I'm going to use here. So we have x plus 4, x minus 2 equals 0. And now that we have this, we can set each one to 0. So x plus 4 equals 0, x minus 2 equals 0. We know that x is equal to -4 and x is equal to 2. So far, so good. We have our x values, but we need to know the y value. So let's start with the x minus 4. So I'm going to go back to my original equation. Let's go with the easier one first. The y equals 2x plus 4. And I'm going to substitute for x when x is equal to -4. So we're going to put that in. And when we do that, we get y equals -8 plus 7. And simplify that more, y is equal to -1. Love that. Now we have that point, -4, -1. So that's one solution. Now what are we going to do with the x equals -2? I'm going to use the same easy equation. I don't want to use the quadratic. I want to use the same one, but this time I'm substituting with when x equals 2. So I get y equals 4 plus 7, or y is equal to 11. So my other point is 211. And that is my solution. Now, this is enough for us to get full credit on this problem. If you wanted to go and do the extra work of going in and then substituting and checking using the quadratic one, you could. So you could just go and substitute when x squared minus 4x minus 1 with those points and also find that that is true. But here, this gives us most of the points. All right, now just to be sure, because I know this is definitely a solution for the first one, this is making me think, yeah, I should go and check with the second one. So let's do our second check. And this one I'll do manually. So y is equal to x squared plus 4x minus 1. We're going to substitute the -4. So 16 minus 16 minus 1. 16 minus 16 is 0 minus 1. So y is equal to -1. So yep, this is true. -4, -1 works. And then we'll do the second one. I'm trying to keep it all on the page here. So y is equal to, this time we're going to sub 2. 2 squared plus 4 times 2 minus 1. So 4 plus 8 minus 1. 4 plus 8 is 12 minus 1 is 11. So this gives us the other point to 11. So also works. Now, because I want people to know my flow of work, how I started, I do want to separate this here. So we can actually see it here. So that I want someone to be able to follow my work and be able to see it. So there we go. So that's it. I was able to solve for the solutions, and I proved it for both equations that my solutions work. All right, score yourselves from a 0 to 4. This is our last 4-point problem. And give yourself a 4 for perfect work that demonstrates it for both equations. A 0 is very clear if you didn't know what to do or you were wildly off base. And if you had some partial errors, I want you to really self-assess for yourself. Do you think you had, or would you be at a 1, 2, or 3 based on the number of errors? Jot it down on the page because you're going to need it for the end, and we'll move on to the next problem. Okay, we're up to the very last 135, our 6-point question. We're probably super tired. I'm super tired. So that means we just have to be really careful and really slow ourselves down because we're going to want to get this over as quickly as possible. But when we rush, we make mistakes. So in this problem, this is a systems of equations problem. And I have noticed the past few years, the last question tends to be systems. So let's see if we can represent this problem and understand why it's a system of equation. So Jen is part of a movie club and she goes to the theater in May and June, and the prices are the same. But notice in May she saw 2 matinees and 3 regular price shows and spent $38.50. And in June she went to 6 matinees and 1 regular price show and spent $47.50. So I hope you're seeing a pattern here where we have 2 different types of movies that have 2 different costs, and she's seen them at different numbers of times. And I can represent this using the equations. 2 matinees plus 3 regular is $38.50. 6 matinees plus 1 regular is $47.50. So I can use those 2 equations to solve the systems of equations. Okay, so that's the very first part. In the second part, they're going to ask me, she said she spent $5.75 on each matinee and $9 on each regular movie. Is she correct? We need to justify that. So what we're going to do is we're going to substitute and figure out, would this be true? So for the first one, for the matinee, I'm just going to substitute the $5.75 for M. So 2 times 5.75 plus 3 times 9, because that's how much the regular ticket is equal to $38.50. Let's see if this is true. And if 6 times 5.75 plus $9 is $47.50, is that true? So you can use your calculator for this. And again, you're probably going to be tired, so it just makes sense not to make a silly mistake here. So $11.50 plus $27 is $38.50. Is that true? $11.50 plus $27 is $38.50. So this is true. Okay, let's do the next equation. So 575 times 6 is $34.50 plus 9. So $34.50 plus 10 will be $44.50. I'm only adding 9, so then that makes this $33.50. Oops, sorry, not $33.50. This makes this $43.50, which is not equal to $47.50. Okay, so is Jen correct? No. Jen is incorrect. The prices for matinee and a regular show given only work for one equation. So it can't be so it can't be correct. So it's not correct. I want to say it can. So the prices are not correct. Okay. All right. So stop there for a moment. Again, remember, whatever solution has to be right for both of them, and we need to be able to justify it and show the work. All right. So let me move this down a little bit. And now we're to the bottom part where we actually have to determine it. And in this case, they're telling us to do it algebraically. We can choose whatever strategy we want. You can do, they're not giving us a graph, so we can't do it graphically. So we can use either substitution or elimination. And when I'm looking at these two over here, I don't want to use, even though I could say, well, I have a R equals. I could figure out R is equal to, and then put the 6m here and substitute. So that's one thing I can do. Again, because I have an R, I could do this minus 6m for R and then substitute this for R up here. So substitution does work. That is a possible pathway. But I think there's another way. And looking at here, I think I can use some elimination. And you might be saying, Sarah, how can you do that if nothing cancels out? Well, what if I did something so that these two could cancel out? So I have a 2 and a 6. Because I know 2 is a factor, if I multiplied this by -3, then I would end up with -6 and then it would cancel out. So that is what I want to do. So I'm going to use elimination. Again, that's the method I'm going to do. After I do this one, I'll show it with substitution, and you can decide for yourself which way you want to do it. You're going to get the same answer anyway. So I'm going to put in my 2m plus 3r equals 3850. Matter of fact, I'm going to put the one I'm not changing on top. And here's my 2m plus 3r equals 3850, and I'm going to multiply this by -3. So I'm going to end up with -6m minus 9r is equal to 3850 times 3, $115.50. Okay, now that I have that, I can combine them together. So now let's put the other one underneath it. These two cancel out, and now I have -9 plus r is equal to -8r, and I can just do -115.50 plus 43 plus 47.50, and I get -68. And now I can divide both of these by -8. And I get R is equal to 8.50. So that is the price for a regular matinee. Now that I have a regular matinee, I can substitute 8.50. So I'm going to use the easy one. I'm going to just use this formula. So 6m plus R is equal to 47.50. 6m plus 8.50 is equal to 47.50. I know I'm subtracting from both sides. And again, you're probably super tired. So instead of rushing, use your tools. So that equals 39. Divide both sides by 6. M is equal to, in this case, 650. And that's it. Now I would go and now check this with my work. So I'm just going to give myself a little bit more space here, and maybe I want to do a check for both of them. So I'm going to do here 6m plus r equals 47.50. R we know is 350. 6 times 650. And with my calculator, I can just put that in. And I do get 47.50. And I could do the same thing with the other equation. So 2m plus 3r is 38.50. So 2 times 650 plus 3 times 850. And we'll do that in our calculators. And I also get 3850. So knowing that, again, I would rather be careful and check my work. Now I have my complete answer. So now you can go back in, and if you use elimination, jot this down into your notes. And now I'm going to erase this and get ready to show it with a substitution. Okay, if you wanted to use substitution, we would take, again, you're looking for, this works very well when you have a variable with no coefficient. So in this case, I have r is equal to 4750 minus 6m. Now that I have this, I can sub it into the other formula. And I want to give myself space here. So 6, whoops, that's the same one I had. So 2m plus 3 times 4750 minus 6m is equal to 3850. And let's simplify. So I'm going to start by distributing. 3 times 4750 is equal to 142. So 2m plus 14250 minus 3 times 6 is negative 18m. Now I want to add those together, 2m, and I'm going to combine these like terms, and I get negative 16m plus 14250 is equal to 3850. I am going to subtract the 14250 from both sides. And you're going to use your calculators for this. 3850 minus 14250, and you're going to get negative 104. And now let's divide both of them by negative 16. And we get m is equal to 650. So that was the same answer we had before when we checked our work. So this works. Now what makes this a little long is I need to substitute again to figure out what r is. So I'm going to have to do this a second time. So here was the first thing I did. And now I'm going to go into the other formula. I'm going to use the 6m. So 6 times 650 plus r is equal to 4750. You can clearly see why I chose that one. And I have 39 plus r is equal to 4750. And now I can subtract 39 from both. Then I get r is equal to 850, which was the other answer we got. So again, if you get these two answers for r and for m, awesome. Again, you'll still go back in and substitute and check it with your calculators. But that's it. This is the last constructive response question. This was 6 points. So go back in, and this is where there's tons of spaces. I like to think of it as, and I'm not sure if this is completely true, the first part is very easy, is can you write these two equations? So giving yourself some credit there. And the second part, you need to be able to say whether or not she's correct. They're going to look for this, like that you can explain it and that your work justifies it. So there are a lot of things they can look for there. And in the third part, they're looking for, can you use whichever, can you use one strategy to solve for m and for r and get both of those correct. So they're looking for that you use a strategy, that you use it correctly, and that you get the correct values for m and r. So using all that, self-assess and give yourself points from 0 to 6 and write it down on your page. And that's it. So I'm going to show you now the point scale for this one so you can start figuring out your points. Okay, this is it. This is our conversion chart. You're going to take your multiple choice questions, all the multiple choice, and you're going to multiply those by 2, however many you got correct, and then you're going to add all your constructed response points together, and that is going to give you a raw score. Then you're going to use this chart and to figure out what your score would be, like what your Regents score would be. And in order to score at least a level 3 on the Regents, you needed 28 raw points. That's it. So either all 14, you got 14 multiple choice questions correct, or some type of combination of multiple choice and constructed response. That's what you would need to get a level 3. Now, to get, so that's how you would use this. Let's say you ended up having 43 points. You would look here and you would figure out, oh, that means I would have a 7. Oh, that means I would have a 72 on the Regents itself. So I'm going to just note the cutoffs. So between a 3 and a 4, you need at least 49 points. And for a 5, you needed 69 points. Now altogether there are 82 points all together throughout the entire test, and that's what you're adding up. The great thing about this is if you know that you are having trouble on a particular type of problem, please put it into the comments if you want more videos on that skill, or you can use this video to identify what you need to study and practice before your next Regents exam. That's it for today. I hope you found this super helpful, and good luck on the Regents exam. See you next time. Bye.